Let's continue with exponent rules, and in this video we'll look at ones based on quotients. The first one says that if you're dividing and the base is the same, the base has to match for this to work, you can subtract the exponents. For instance, if I'm simplifying this expression, notice I have 11 factors of 10 and 7 factors of 10. That implies I'm multiplying 10 over and over again 11 times, the key word being multiply. And in the denominator, I'm multiplying 10 7 times, so there's 7 factors of 10. Once I start reducing common factors of 10, I'll be able to do that 7 times. Once I've done that 7 times, I'll still have 4 factors left in the numerator from my original 11 factors. A fast way to carry out that idea is to simply keep the base of 10 and subtract 7 from 11 to find the difference. That means I can write this simpler as the fourth power of 10. With powers of 10, we often tend to write them as a value, in this case 10,000. Here's 4 for you to try. For the first one, I'll keep a base of m, I'll subtract 8 from 18, and get an exponent of 10. For this one, it's going to be negative because when you divide and the signs are different, you get a negative result. My base will be q. I'll subtract 8 from 14 and get an exponent of 6. For the next, I have two bases, 2 and y. For the base of 2, I'll subtract 12 from 15 and get 3. For the base of y, I'll subtract 6 from 8 and get 2. Usually we'll simplify 2 cubed to 8. For the last one, I'll have a base of m with an exponent of 14 minus 12, which will be 2, and a base of n with an exponent of 3 after I subtract 6 from 9. Now, let's look at the power of a quotient rule. If we have a power and the base happens to be a quotient with different bases, we can give the exponent to each of the bases individually. To simplify this expression, for instance, I could square 3 and also square 5, and I'd get 9/25. Here's 3 for you to try. For this one, I'll square x and I'll square -3. The quantity -3 squared is 9, and so there's my simplified quotient. For this one, the factor of -1 will get an exponent of 4, as will the base of x and the base of y. The fourth power of -1 is +1, so there's the final quotient. And for the fourth one, my bases will be -6 and h, and the quantity -6 cubed is -216. Now let's look at a rule that people at first find pretty confusing. That is, if your base has an exponent of 0, you can replace that with the number 1. For instance, to simplify this expression, I can simply replace it with 1. See if you can do these 3. For this one, remember this exponent of 0 is not affecting this idea of negative or opposite out in front, so this would just be -1. Here, because of the parentheses, This is the base, so the entire expression is a positive one. And for this last one, the base being the 15th power of m divided by 2, it really doesn't matter that it's getting more complicated. If its exponent is 0, then it's a 1, and in this case, a negative 1. The last rule we're going to work with is probably the hardest. It's the negative exponent rule, and it talks about reciprocals. If we start with a base of x but a negative exponent, you can replace this with the reciprocal of the original as long as you change the sign of the exponent. In this case, the reciprocal would be 1 over x to the negative m, or opposite of m, but when you take the reciprocal, you make the exponent opposite. And in the same way, here, the reciprocal of this would be x with an exponent of negative m. But again, when we do the reciprocal, we change the sign of the exponent, and so this can be replaced with just x to the m. To simplify this, for instance, I think of this as a fraction with a denominator of 1. Its reciprocal will be 1 over 3 with an exponent of negative 2. But when I make the exponent opposite, it'll be 1 over 3 squared, or 1/9. Try these three. For this one, I think of it as the numerator of a fraction. The 2 is not being affected by the exponent, so it's just going to stay in the numerator. But the base of k will go to the denominator, and the exponent will become positive 4. For this one, the y with an exponent of negative 5 will go to the numerator, and the exponent will become positive. You don't have to write this 1 here. You can just write y to the 5th, and that's fine. For the last one, the exponent does not affect this idea of negative or opposite. This base and exponent will move to the numerator, and the exponent will become positive. And then when you have a quotient and the signs are different, the result is negative. I decided to square 8 and get 64. And here's the last 4. For the first one, this base will move to the numerator. It'll become 7x to the 7th. For this one, both bases have to move, and both exponents become opposite. For this one, this already has a positive exponent. It's going to stay in the numerator. But this one is going to have to move to the numerator and have a positive exponent of 3, which is just 64. The last one, the base of 4 will come to the denominator. The base of k will go to the numerator. The base of h will stay where it is because it has a positive exponent. And I'm finished. You don't have to write the exponent of 1 here. We usually don't. Well, that concludes our work with an introduction to the exponent rules.